let's compute the flux of f, which is y1 minus xz. Through this surface, y is x squared plus z squared, with the restriction x squared plus z squared is smaller than 1, oriented towards the positive y. Okay. They said flux, right?
Yep, so that's...
So I should write this down. Integral f dotted d area.
I think that's still going to be some points.
Hey, 1 point.
Surface. Right? Okay, next thing. You need to get a parameterization for your surface, right? Okay, so you need a r of something. Yeah, so I'm looking at this thing and I'm looking at this disk here, and that disk is causing me to think disk, which is then causing me to think polar. Right, so I'm thinking like, okay, x is r cosine theta, and
I can't remember. Y is R sin
Z is
theta.
R sin
I
theta.
don't. Oh,
yeah,
Z is
y
R sin
except
theta.
it's c.
But I thought because
The
it's
Z is
crossed the
active.
other way, I switched it.
Yeah.
Like R is, or X is sine theta and Z is cosine theta.
Sure, yeah, you can switch the order. That's not going to matter too much.
Okay, I was just wondering because I was like, I feel like it was.
Okay, so I'm thinking r's and thetas, right? So I'm thinking, okay, r is going to be a function of r and theta. So I really probably should use a different whatever, not. And what is that formula going to be? What is your surface? Like,
The disk.
I think it's R cosine theta.
so your surface is y is x squared plus c squared, right? What's x squared plus c squared if x is r cosine theta and z is r sine theta? R squared. Right? And that's what goes in the y slot.
Oh my gosh.
What goes in the x slot? R cosine theta. What goes in the z slot? Whatever z is. R sine theta.
My gosh.
You guys see that?
I see it now.
Yeah.
Okay. So then you need to do these, right? You need to do the partials. R is
Cosine theta 2R sine theta.
cosine theta, comma 2r, comma sine theta. And r theta is
Negative R sine theta.
negative r sine theta,
0.
0, r cosine theta. Yes? Kind of?
Yeah.
And then I want to cross them in this order to get pointed towards the positive y's. You guys see that? Okay, so if you cross these, r crossed with r theta, what do you get? 2r squared cosine theta, and then r cosine squared theta plus r sine squared theta. So that's an r, right? And I should be subtracting that one. So I got a minus r. And out of the k's, you get a minus 2r squared sine theta.
Don't the minuses cancel out?
Yeah.
The minuses cancel out, I'm pretty sure.
You got a positive r?
Yeah.
Did you forget to subtract that j component?
No. That's like what because it switches over, it converts your negative. It should be a positive.
Yeah,
Right.
the first cross is 0.
Yeah.
R cosine squared theta. Did you take
You're doing your j component, right? That's the one we're talking about?
I'm gonna, because I switched my x and
You're doing cosine times r cosine is r cosine squared minus negative r sine squared.
It's because I did. It's because
So
I
that's a
switched
plus
my X's
r
Z's.
and then put a subtract on it. Yeah, and if you switch if you swap the sine and the cosine, it'll be a positive r.
Okay, that
Because you're pointing in the other direction.
Right.
For that, right, for component z, don't the negatives cancel each other out and you end up with a 2r squared sign?
And the z component, you got, yes, thank you. The z component should be positive 2r squared sine theta. Okay, and then what?
Then, I mean, we have our f of r. F
Yep,
of r.
so you need to take this thing, right, and have the integral, right, double integral of f of r and theta, right?
Yeah.
So you need f, y is r squared, comma 1, comma
This doesn't look like doing that.
negative x times c. So you got negative r squared sine theta cosine theta. And then you're dot producting that with all this stuff. 2r squared cos theta, comma minus r, comma 2r squared sine theta.
I did it.
And you should be integrating dr d theta, right?
Is it r dr d theta, or do we have the conversion factor? Or? No.
I do not need the conversion factor because that's accounted for in my cross product.
Okay.
What are your bound stuff?
0 to 1 and 0 to pi.
No, is it negative 1 to 1?
It's a radius, so it's just 0 to
So
pi.
to
yeah,
cover
yeah.
this disk, right, I need a radius from 0 to 1 and a theta from 0 to 2 pi. And that'll get you a number, but I don't have time for that.